What if one of the biggest challenges in shipping was invisible? Every year, billions of tons of ballast water are transported across the globe, carrying microscopic organisms from one ecosystem to another. A silent threat, impacting biodiversity, fisheries, and global economies. Today, treating ballast water is no longer optional. It's a global regulation. But behind compliance, there is a fast-growing ecosystem of technologies and innovation. In this episode of BlueTech Around the World, I speak with Maxime Dedeurwaerder from BioUV Group. We explore how ballast water become a global environmental issue, how UV technology neutralizes microorganisms without chemicals, and how the market is shifting from equipment to services and operations. From shipping to aquaculture and offshore wind, these technologies are reshaping the blue economy. Because water is no longer just a resource, it's a system to manage sustainably. Listen now on BlueTech Around the World.
BlueTech Around the World, the reference podcast for blue technologies and ocean innovation.
Welcome to BlueTech Around the World, the reference podcast for blue technology and ocean innovation powered by Blue Connection. I'm your host, Marie-Lucic, and in this podcast, we explore how innovation is transforming the way we interact with the ocean. Today, we are diving into one of the most crucial but often overlooked challenges in the maritime world, which is ballast water management. Every year, billions of tons of ballast water are moved around the globe by ships, and with them, millions of microscopic organisms each ride across oceans, and sometimes inviting new ecosystems, disrupting biodiversity, threatening public health, and causing billions in economic losses. And since the entry into force of the IMO Ballast Water Management Convention, treating ballast water before discharge is no longer an option, it's an obligation. And at the heart of many of this system is a powerful yet elegant solution, which is UVC water treatment. And to help us understand this critical topic, I'm joined by Maxime Dedeurwaerder, head of the Maritime and Industrial Solutions division at BioUV. With more than 16 years of experience in the maritime, natural gas, and renewable energy sectors, Maxime also serves on the board of directors of the Ballast and Environmental Manufacturer Association, contributing to global ballast water and environmental standards. With his deep technical and strategic background, Maxime is a perfect guest to help us decode the science, technology, and market dynamics behind ballast water management, and to show how innovation can make shipping safer for oceans. So Maxime, welcome to BlueTech Around the World.
Thank you, Marilu. Very happy to be here.
Thank you for accepting the invitation. So before we go into the technical aspects, could you briefly tell us how you started working on ballast water treatment and maritime technologies?
Sure. I have a marine industry background, and I know that you have met a lot of people from the marine industry and the marine environment, and you know how we are. We are just passionate about our industry. I come more precisely from marine equipment. I had the chance to work on various equipment that goes on ship. And one day I happened to be in touch with this small French company with a lot of ambition that wanted to penetrate further the ballast water treatment market. And as somebody with marine equipment background, I was a good person to support the company to do this move, knowing that BioUV, our company, we'll discuss that, is initially well-versed into water treatment and not from the marine industry to begin with.
So that was the perfect match for BioUV to have you in their team to penetrate the maritime sector. So looking forward to hear more about that. So first, in order for our listener to better understand the topics, let's start with the basics. So what exactly is ballast water and why do ships need it?
That's a good point. From the outside, I guess it can be surprising, but we add weight on purpose on ships. We want to add weight to them to balance vessels. And the best way to do it, of course, is to use what is immediately available, which is the water surrounding the vessel. So the concept is about loading on board in tank dedicated to this use some water and to unload it when we need to take off some weight from the vessel. And this water taken from the ambient environment is called ballast water. So the final goal is to ensure the balance of the ship, from bow and stern, starboard, port side, but also what we call the vessel draft, which is how deep the vessel is sitting in the water. This is going to be used in general for maneuvering, for instance. Any ships will need it as well to compensate, the use of fuel on board. When you bunker, then you have fuel on board, and so it adds weight to the vessel. So here you release some ballast water. And to the contrary, when you are running out of fuel or you have less fuel, then you compensate to keep the same balance by adding ballast water. Ultimately, the biggest user of ballast water are the cargo vessels, because they have a very important weight variation through their operation. So bulk carriers, tankers, and general cargoes and container ships are the biggest users of ballast water.
Okay, so ballast water is essentially the water in the ships that help them stabilize, or like an adjustment measure, for example, for fuel consumption.
Absolutely.
And so what I understand is that they discharge the water, for example, in the next port, so often like thousands of kilometers away. So what are the main issues and problems linked to ballast water discharge exactly?
There's a lot of life in our oceans. I'm sure you know that, and we all know that, and we should probably be more aware of that, but there's life. However, when you bring some living organism from one spot to another, then you can have the same mechanisms than what's happened inland, which is invasive species. And that's what actually happened through history. There is some very well-known cases where we know for sure that the invasion were caused by ballast water carried by ships. The names are famous: the blue crab, for instance, the jellycamb, which both of them has been found into the Mediterranean Sea or in Black Sea or Caspian Sea, where they had nothing to do. They were from other places, either from the Americas or from Asia, and they caused a lot of harm to the local environment first. We all know the importance of preserving our resource and our natural environment, but secondly, also very strong economic impact on the fishing industry to begin with. So it's an issue that appeared through times, in particular in the second part of the 20th century with ballast water. Just to give an idea, that's good to have some proportion, but we estimate that every year there's about 10 billion tons of ballast water that is moved around the planet. So that's quite a good amount of water and enough to carrying some organisms.
Yeah, I always find this part striking, like ballast water is like an invisible vector of global change, because some of the invasive species, you mentioned the blue crab, there's also the zebra mussels in North America,
Absolutely.
could spread this way. So it's kind of a silent threat that often goes unnoticed until it's too late, actually. And so I'm curious, how did the industry traditionally deal with this problem before regulations came into force?
The industry did not deal particularly with this problem. There's a way to slightly prevent the invasion. It's to exchange the water at sea, far from the coast. But even by doing so, you can keep some of the possible organism in the ballast tanks that are subject to be released in a port. Plus, a lot of the ballast operation are done in ports. The industry was simply not addressing the issue.
So what does it change? Can you explain the role of the IMO Ballast Water Management Convention? What impact does it have on the practices at sea?
Yeah, so the convention, which was ratified in 2017, and after being adopted in 2004, so it's a long process. If we can make it simple, it requires all ships to treat the ballast water, and the regulation falls on discharge. That means there's a certain quality of water. In this case, a certain level of biological composition in the water that is required by the convention. So all ships must treat their ballast water as long as they travel internationally between areas that have ratified the convention. And to make it simple, it's pretty much most of the world, big part of the world. And for that, they need to be equipped with a certified system from any seawater quality in entry, the targeted quality in discharge. To give just a little bit more on details for the biological aspect, the convention rules address the question on two aspects: the type of organism, so it mostly asks for the system takes off some targeted pathogens, such as E. coli, for instance. And then the requirement is the number of living organisms by their size within a given amount of water. So there's two categories: organism of over 50 microns and organism below.
Okay, so there are like strict regulation. You need to be certified, and you need to have these two methodology with different criteria. And so what techniques or methodologies have been used on the market so far? What's considered as the state of the art today regarding these techniques?
And one of the key technology used is the one we provide, which is a two-step treatment process. We start with physical separation, so that's filtration, and then UV disinfection. This technology covers around 60% of the ships today equipped. Once again, always good to give some idea of the proportion. The number of ships that had to install a system according to the convention rules, it's about 50 to 60,000 ships worldwide, roughly. So 60% of them have been equipped with a filtration plus UV system. The two other technologies that cover the rest of the market are electrochlorination and chemical injection. So chlorination, that also comes sometimes with a first filtration step. Chemical injection, which is a bit different. It's not the water going through that is treated when it's transiting from the ambient environment to ballast tank or on the way out. It's treated directly in the ballast tank through injection.
Okay, so really interesting, like different kind of methodologies, the chemical chlorination, and of course the UV disinfection. Most of them need the first step of the filtration. So now I'm curious. I want to know more about your solution. You just say that ballast water can't just be discharged anymore. It needs to be treated before being released into the ocean. And as you mentioned, one of the most widely adopted methods is UVC disinfection combined with filtration. So can you tell us more about how it works actually? How this technology works?
Okay. So the first step is filtration, as you mentioned. So filtration is quite easy to imagine what it looks like. It's like the drainer in your kitchen, just a cover of these very, very small holes, and on only anything that is smaller than those holes that are going through. So in our case, the grade of filtration that we are using is 20 microns. So in the water, anything that is more than 20 microns is not passing this step. This has two very nice advantages. The first one is that takes off first part of the organism targeted by the convention rules, so anything that is bigger than 50 microns. The second thing is that the filtration will nicely help the UV disinfection step, because it will get the water that is a little bit lower in terms of turbidity. Then the water goes to UVC, precisely as you say. UV treatment is a technology that has been existing for a long time, over a century. There's different type of UV. So UVC is what is used in water treatment. If we want to make it simple, UV is just light. Simply the wavelength is quite different from the ambient light, 154 nanometers in the case of UV treatment. And UV is, I would say, tackling the organism DNA and disorganizing the way of working of the DNA when it comes to reproduction. So it's actually what UVC is doing. It's not necessarily killing per se the living organism, but it's preventing them from reproducing. So that's the way living organisms and pathogens are turned harmless.
Okay, so UVC light scrambles the genetic code of microorganisms so they can't reproduce, which means that they are actually effectively neutralized.
Yeah, we can put it this way. Yeah.
Okay, and why is this method, so UVC, considered safer and more efficient compared to the other methodology you just talked about before, like the chemical disinfection? What are the difference, and why are there are more boats using this technology rather than the other?
The other technology are safe as well. If they are certified, then they are safe for users and safe for the environment. I think that UV has been chosen for various reasons. Compared to the other technologies, the installation and the operation of those systems are relatively simple. There's only two main components, the filtration and UV, that are then coordinated through a single automation system. And the second one, I would say, and this can be interesting, there's no need for the crew on board to handle any chemical matter. All the system is fully chemical free and not need to use chemicals as an addition, because in injection system, you need to store the chemicals on board, the one you inject. In electrochlorination, there's no chemical in the process itself, but there's a need of chemicals for the neutralization of potential residual chlorine on the discharge. So that's the way this technology is working. So that's one of the reasons. And then other aspects came in also in the picture, is that no technology is perfect, because seawater is a very challenging environment. UV is not sensible to salinity. It's not sensible to the water temperature. For that respect, the systems, if they are systems of quality, because that's also one criteria, then the technology will allow to operate in most of the seawater conditions. So that's one of the things that is also appreciated by the market.
Really interesting, like that it could be resilient technologies that would apply everywhere. And what does the installation look like on board? Like, where is the system located? When is it used? On what type of vessel? Can you tell us concretely how it works on the operation of the ship?
Yeah, so systems like filtration plus UV and other technologies that will treat the water during transfer, they are mostly installed in the vicinity of the ballast pump. So the ballast pump, it can change from one ship type to another, but they are themselves most of the time in engine room or nearby the engine room. It has been equipment that needed to be added to existing ships, which were quite challenging because they were not planned to be there to begin with. So it was like scrubber retrofits or other equipment retrofits. You had to find the space to put them. So usually they are installed in the vicinity of the ballast pump. And on existing ships, you don't have the chance to put them in a nice room that is dedicated to it, because I said they were not planned to be here when the ships were built. So you have one component in one place, and whenever there were another empty space, you have some new piping running to the second component. And then after the treatment, it goes back to the main ballast line, and then the ballast systems with a set of valves and piping is doing its job to bring the water in the tank where it needs to be.
Actually, it could have been a challenge for your engineers in the team, trying, depending on the ship, finding the best place to adapt with the retrofit of the ship.
Yeah, and unfortunately, it's not always or rarely us that has to find the solution for this. There's third parties involved, shipyards or design companies that are addressing the issue for the ship owner to where should we put the equipment on.
Yeah, so when we want to add a new technology, a new solution on a ship, that there is this collaboration between the ship owner, the shipbuilder, and the technology provider to see how to implement and operate the solution. So that's a really good point that you are sharing right now. I'm curious, could you share a success stories or a project where BioC make a big difference for a ship owner or an operator who are using your solution?
Yeah, I could take an example. First of all, I mentioned it. We are one of the suppliers with similar technologies compared to other suppliers. As a matter of fact, I believe the ballast water treatment industry is a very healthy market because there's plenty of different options for ship owners. Every supplier is having his field of specialty and bringing one specific big value in some specific cases. In our case, one of our specialty are the very small systems. We do every type of systems, but we have developed a range that were dedicated to very small needs. And I mentioned earlier in the discussion that in some existing ships, ballast water treatment plant was not planned to be here. So it's sometimes very challenging on some ships, and sometimes it's even nearly impossible. So I'll take an example, which I hope we will be able also to illustrate with image. But we found actually 2 times clients with a very specific type of vessels, which are named SWATH. So SWATH are small water plane area twin hulls vessels. That's what it is. So it looks like a catamaran, but it's not exactly a catamaran. And the way ships are designed is that they have ballast on the two sides, on their two hulls. So they have two hulls. And they have the additional difficulty, which is you sometimes find in the industry, but which is rare, which is that they had two separate ballast systems, which means they had to install two systems in circumstances that there were almost no possible place. But fortunately, after looking a bit everywhere, they found the solution with our very special equipment, where we have extremely compact systems for the smaller needs in ballast water treatment. So that was an interesting journey for them after spending months finding a solution and getting crazy about trying to fit different drawings and finally find a solution with that.
Oh, so that's great. So even if you are, providing solution to all the kind of ship owner, you position yourself like the best solution for really compact situation and operation with your
Absolutely.
specific solution. So that's a good positioning. That's good to know for like your differentiation and value proposition for the market.
That's one of our differentiating points. Yeah.
Perfect. Good marketing point. So as you mentioned, the installation phase is mostly behind us because
Absolutely.
that the regulation is there. So I think now they are more like focusing on the operation and maintenance of the system. So how do you support your clients through the entire life cycle?
That's a good point, Marilou. And you highlight there something that is very important to, I guess, to understand about our market, but it will sound familiar to anybody that has been providing equipment that's aimed to comply with environment regulation, especially in the marine industry. There has been two phases. The first one is we as ship owners need to comply, and we will comply because that's what ship owners do. They are respectful toward the regulation, and they are in constant contact with their classification society, with their flag administration. They had to get equipped. So they get equipped. And now everybody is equipped, pretty much. There's a few exceptions, but everybody is equipped since September 2024. So it was the compliance phase, let's say, the equipment phase. Now we are slowly but surely leaning towards the implementation phase. And this goes at different level. It can start with actually on the field with the crew handling their systems every now and then. They understand that now they need actually to use it for every ballast operation and realize that since this equipment has been installed, the crew has changed. System was not maybe used that much. So it's not operating and it's not operating well anymore. It needs to be maintained. There's also, those systems, either our technology or others, is full of sensors, and those sensors need to be calibrated on a regular basis. So ship owners need our support, and we are here to support them to ensure what we call their service and maintenance. So we are here to provide spare parts, and we have a network of certified service engineers around the world to go on board and support them in knowing how to operate their systems, to run the maintenance on their systems, and reaching two goals, and which is to have a system that is working and treating as per the convention, and also then maintaining their certification and their compliance. What happened on the field obviously has also consequences, and it's following the same path at higher level, we see at regulation level. So at the IMO, the discussions continue. The convention is here implemented, but now it's the evolution of the convention, the changes in the rules, the regulation environment, and actually how the systems are operated that are subject of discussion at every level. And the people that are actually in charge of making sure everything is applied, I would say the watchdogs, such as the port authorities of those classification societies, they are also now implementing what's in the convention within their guidelines and their habits. For instance, this year's Memorandum of Understanding of Paris, the Paris MOU, which is gathering the port authority of most of Europe plus Canada, had a special focus on the implementation of the convention within their guidelines. So the port authorities start to actually make sure that their people on the field know the systems, know the rules, and are integrated in the guidelines, the survey, to make sure everything is in compliance. And as manufacturer, of course, we are involved in those discussions. We are not involved by ourselves. You mentioned it at the beginning of the interview. We are also a member of BIMA, which is the Ballast and Environmental Manufacturer Associations, which aim to gather all the all the well-established stakeholders of the ballast water and biofueling industry. And we are, as manufacturer, stakeholder of the discussions of different regulation and regulation implementation.
I think it's really interesting to understand this shift. So first, really to have the technology on board. So it could be an easy sell because there is this regulation, this legal drive for that. But then there is, of course, the implementation. How does the team on board use it? Maintenance. You were talking about the sensors too. And so I think it's also a completely shift on how you, as a technology provider, you're here to support the entire industry on how to use, how to maintain. And I think it's also another kind of relationship with the industry. So it's really interesting to see how the ship owner adapt, or the technology provider adapt, but also all the international organization like the IMO or your association are working on that kind of subject. And that just opened me another question, which is like, okay, behind the technology, I think there is a huge market and strategic dimensions. Just to give us an idea, you already give us some figures, but how is the market today? How is that evolved since the regulation came in, and what are the projections for you? How do you see the market growing for you?
I mean, if we talk about ballast water treatment systems itself, the market is not going to grow, evidently, because it has been a big retrofit boom that peaked around 2022, 2021, 2022. And now the equipment level is going down, and anything that's going to remain for ballast water treatment, strictly speaking, are new build vessels. However, the service side second market retrofit will continue to elaborate and to develop the replacement of old units that are failing and not doing the job anymore. And you have clients interested to step into a maintenance agreement to hand over the management of the system to you and make sure that you guarantee compliance to them. You know, that's a big difference we have compared to other marine equipment maker that came to ballast water treatment, is that for us, we came to this through the technology. Our specialty is UV disinfection and ozone disinfection first, and also a couple of other technologies as well. So we can redirect also our efforts toward other development, while we, as I mentioned, we still grow what we call the aftermarket, the after sales activity for ballast water treatment system. And having developed ballast water treatment system can be very useful for other applications. The system itself, because now we have a nice ranges of very efficient systems that can handle very tough seawater with a combination of filtration and UV with a single automation. But also, I would say the knowledge, because that's the first resource of a company, that's their people. And have teams that handled projects before, tough implementation, as you mentioned, tough installation circumstances, and this can be applied in other fields.
Really interesting. And actually, we're going to come back later on the different application of your solution in other sector of the blue economy. But it's great to see that, as you mentioned, you are a technology driver to penetrate the market. And so I'm a little curious. I want to benefit from your experience. So how do you approach actually international markets? What is your go-to-market strategy for ballast water treatment?
For ballast water treatment systems to be, we were a little challenger in this market. So to be known, you had to have people introducing you to ship owners. So we relied on a network of agents and distributors of trust in different territories. Then there's been, segmentation made that was based on the strength and the flows of our technology or system designed. So if we talk about ourselves, for instance, we are very strong on the yacht market. So we put focus on this one. If there's one segment where BioUV is known for ballast water treatment, so BioC, our brand, it's the yacht industry, which is with an industry with high expectations, but also very concerned about the fact to be comply with all the regulation, to show that they are willing to comply and to be in line with that. We developed a different set of specific options enjoyed by the yacht industry, and we got a strong position in this one. On the other hand, we did not target the oil tankers and LNG carriers, for instance, because systems that were requiring specific explosion-proof certifications, which we did not develop. So that's simply segmentation. all average size vessel, which is general cargoes or OSVs of offshore supply vessels, has been in our target, and we run after them.
Thank you for your insight on that. And you just mentioned before that you have kind of an indirect go-to-market strategy relying on partners, a key contact on the different markets. And as we just said before, it seems that it's a real intricate market where you have the ship owners, the ports, the engineers, as a ship builder. So what do you see as the main challenges for adoption today? How do you become part of this ecosystem when you are new in the maritime industry?
Ship owners, but it's true in every challenging and industry and industries that are relatively heavy in terms of assets. They are relatively conservative, and it's not always to get there as a newcomer. So at the very beginning, I was not part of BioUV at this time. The person that were leading the first steps of BioC managed to be trusted by different ship owners, mostly French ship owners. Sometimes, it's always good to start with those domestic markets, but also in Italy and Spain. And once you start having few references, then you have the proof that your system can be a good choice, and you start from that. For a lot of ship owners, it was a little bit of pain, this installation. We can understand that because there's no return on investment for them. It's compliancy without return on investment at all. It's pure cost. And I think we have to remember that we also we have ship owners with substantial dimension, with technical staff and such. But you also have smaller ship owners in the market, operating 2, 3, 4, 5, 10 ships maybe. And one of the things that helped us, I think, getting into this market is being collaborative, and I would say being helpful, and come with them not only with the standalone system as a solution, but also to driving them for the design aspect, taking the time to explaining them the convention sometimes, and also technological aspect. And, it's like for any business, if you see that somebody is by your side now, they're going to be by your side tomorrow. So we, as a small actor in the market, we were not necessarily always working with big actors. Sometimes we did, sometimes we do. But we went also supporting ship owners of, I would say, a more modest dimension. And we provided them with design services. That has been part of our also portfolio system, but also the design how to integrate it. So it's a turnkey project, and it has been very appreciated.
Really good strategy to have these complementary services, not only the product, the solution, but also the services behind. Always good when you are in a competitive market where you rely only on regulation and it's only cost for your customers. So good move. And actually, we just mentioned it. BioUV's expertise doesn't stop at ballast water. Your technology is also used across the whole blue economy. So let's start with aquaculture, which is one of my favorite topics. The industry is shifting from open sea farming to land-based system, especially with the rise of RAS, which is recirculating aquaculture system. So how do UV systems support fish health, biosecurity, and water quality in aquaculture today?
To talk about the role of UV in aquaculture, you are right, we need to talk about RAS to begin with. UV is a disinfection technology, so it addresses all the biological challenge. So obviously, when you're here with living organisms, with fish that you need to preserve and are concentrated on a small space, UV has a very important role to play. It can be used, for instance, on the intake water. It can be used in the circulating water, going from one tank to another. It can be used on the effluent water. In general, of course, the added value of UV would be pathogen control. But we could mention also ozone, which is the other technology we handle, which is also widely used in aquaculture, is really contributing to an improvement in terms of sustainability, because it contributes to the well functioning and to the development of RAS. And Marilou, I know you know the topic perfectly, and RAS don't always necessarily have a good image, but in reality, it's really a great way to improve the sustainability of the fish production industry, and by bringing a way better control on pathogens and on environmental impact. And UV's treatment is definitely contributing for that respect.
And actually, you are totally right. One of the best advantage in RAS is that we can have a perfect control on the water quality, the environment for the fish that we can't have in open sea. And with like climate change, rising of temperature, etc., acidification, there are a lot of environmental factors that have an impact on the health, the growth of the fish. So having this environment control area is really important in RAS. So really a big topic, and it's really important that we have this kind of technology to help the aquaculture industry move forward regarding fish health, biosecurity, and water quality. So today, just to give us some figures, what does the aquaculture market represent for bio-UV? And do you still position yourself here as a challenger, or what's your position on this market?
Yeah, we are a challenger as well, for sure, comparing to the size of the industry. And, I mean, the aquaculture and RAS industry is growing fast, as you perfectly know. However, we have very suitable solutions, and with the technology that has, there's no RAS without UV. I don't think it ever exists. The aquaculture is not one of our main business. I would say it's probably represent around 10% of our turnover. Nonetheless, it's one of our key axes of development, one of our key targets, because we actually brought ozone within our technology portfolio through an acquisition. Also now a few years ago from now, and the integration is not fully done, so we can come with very interesting package with ozone and UV, knowing that one of our other key position is, and we mentioned it for ballast and the same across all our lines, is to not just be equipment supplier, we are solution supplier, so we can take part before the sale to the definition of the solution, but more importantly, we are supporting through the full life cycle of the system. So we are here also with service capacities. So that's something that the aquaculture industry is looking after. So we today have several important projects in development, and thanks to our ranges of systems in UV, and now it's the same, with ozone, we plan to expand widely in this direction.
Okay, so we have this combination of UV and this combination of ozone to have this impact and treatment of the water.
Ozone will also act as a disinfectant, but it depends on what you want to do and what you have in quality water and the entries. They are doing the same goal, but not decided the same way and not in the same circumstances. You also have sometimes, we didn't mention them, but both OUV and ozone can have a role that goes beyond, or that is different from disinfection. For instance, ozone is used for water clarity. So that's one of the reasons why ozone is also used in the pool industry or in other industries. And it will have also the nice effect to ease UV treatments by improving the clarity of the water. So that's one of the other possible use of ozone. Ozone can also act as an odor removal technology. It has many applications. They are both very complementary technologies.
Thank you for guiding us through your solution in the aquaculture industry. There is also another sector that is floating offshore wind. So I've made an episode regarding offshore floating wind this year. And it's strange because here we are not talking about water in the traditional sense, but like on the floating structure, which still have ballast system actually, and that need to be managed. So can you share an example on how your solution are applied in this context of offshore floating solution?
Yeah, it's true that we had a case where we provided a solution for a challenge that the operators were facing. Some of the offshore wind farm projects are based on a principle of floating turbine. So that you have the turbine and the base is floating, and sometimes it can be floating and be in half inside cement and water, and cement and air simply, or water. And in this case, we can legitimately call this water ballast water because it's used to balance and to adjust the draft of the structure. That's exactly like as for ships. So in the cases we have seen, and it was on one of the big projects in France, nearby where our factory is based, actually. The stakeholders realized that at some point that through the construction process, they were about to load some water at a given point and then discharge this water somewhere else. We are talking about a quite substantial amount of water. So there's been some question about the application of the convention or not. Aside of that, anyways, there were some public authority concerns. What is this water? Can you guarantee that you are not releasing anything harmful in the local environment and so on? So that's where we came in the picture, because that's having a ballast water treatment system, you perfectly know discharge quality. It's documented, it's certified, and it has been applied many times. So here, we are not talking about installing a system on the wind turbine, of course, but we provided a containerized solution external to the stakeholders, to the operating ports in particular. That was where our first point of contact for this project. And then it was then possible to treat the water at discharge. The situation was not the same than on a ship, because on a ship you need to treat the water when you're on the intake, and you have to do a little bit more UV on the way out as well to guarantee the treatment is done. So in this case, it was a containerized solution. We treated the water one time, went in the tank, and then treated again on the way out. I mean, there's been a full specific design made so we could treat the water, and the operators then could have answered the authorities that they actually treated this water and that they were not going to harm the local environment.
I love the story when there are some dots and connection between the different sectors of the blue economy. So here, floating offshore wind and ballast water treatment. And interestingly, here, it's not like the international regulations that has been a driver. These are the local authorities
Absolutely.
and the environmental expectations that have pushed for the solution. And I think that both the technology provider of the floater for the floating offshore wind and you have to innovate, have to adapt on the operation, on the system for this new application. So I like this story very much, with this interaction between two different sectors of the blue economy and how we push forward more innovation. So thank you for sharing this with us. So beyond aquaculture and offshore wind, I know you are also present in other industrial wastewater treatment, aquarium, oceanographic centers, and even cruise ship with the swimming pool, I would say. So can you give us some example on this application?
Yeah, in one word, BioUV is a water treatment specialist, and more particularly focused on disinfection, thanks to the three technologies that we handle, which are UV, ozone, and salt electrolysis. We have been present in any type of application where those technology can be used. Core business, or I would say, the genesis of BioUV is a recreative business. I would say we led the development of the use of UV in the swimming pool industry, which is something that is important to highlight because this represents an alternative treatment to pure addition of chlorine in the water. So that's one industry where we are strong. That's one of our core business, the recreative business as a whole. We have always been very present in the aquarium industry. And then UV is widely used also in the drinking water industry. That comes as a security step. When you have some potable water that has been stored, the castle, for instance, when you take it out to make sure there has not been, contamination, then a good UV treatment is most of the time applied. And wastewater, the treatment comes as the last and ultimate step. When you have wastewater treatment plants everywhere around the territories, there's very often UV as a final step. We have also projects where ozone is used in the main process of wastewater treatment. Finally, another thing where we all have been there and where we're going to increase our development is industrial applications. Every type of industry is treating their water. So there's two things. There's a process side. Our technology is going to be used when there's concerns or when there's need to address the biological aspects, so disinfection. It's going to be particularly true in the pharmaceutical and the food and beverage industry. And then any industry is going to have also a concern on the effluent. That's something that is more and more taken seriously by the industrial world. And in any effluent treatment, ozone and UV can probably be applied. So that's our current portfolio. So that's one of our strengths, thanks to the fact we have technologies applying in a lot of different circumstances around the blue economy. Then we are working on various fields and various applications. So we are a little bit everywhere.
Yeah, that's an impressive portfolio that you have. I think it's a really good thing because you can transfer some expertise and experience from one
Exactly.
sector to another one. And also, we mentioned if there is at a moment from any regulation, economical, whatever that impact one of the sectors, you have diversify your activities because you are technology driven. So just one more question. Where do you see like the biggest growth potential regarding all these different applications that you have?
We mentioned RAS in aquaculture. The forecast I mentioned an increase of 10% of volume minimum per year for the coming 5-10 years. So this is gonna definitely be an axis of focus for us and growth. And then, as I mentioned, in industrial application as well. One of the big turn in the water industry where we're gonna play a role as well is the evolution of reuse. I think one of the main, we believe that one of the biggest change today in the water industry is not necessarily from the technology perspective, strictly speaking. There's no major, I would say, cutting edge changes in the technologies. They are evolving, sure, but what's going to change in the mid and short term mostly as our behavior and concerns. And water reuse is now appearing in people's speeches everywhere for different reasons and through different aspects. We believe there's still needs some time for regulation alignment. For instance, we mentioned ballast water treatment. What allowed ballast water treatment to become a reality and to have all ships equipped around the world today was thanks to regulation standardization and certainty. Some, perspective and some certainty on what the regulation is going to be and where it applies and such. So this helps. And so probably that's what's needed for reuse. And we already start some development and some specific equipment and product for reuse. And that's where we have all our chances to play a role. And because UV and ozone can definitely play a role in that.
Thank you very much. Reuse is a really important point and hot topic, actually. Next, peak water on water, marine and maritime from the European Union. Strong insight on the water reuse. Finally, last question. What advice would you give to someone who wants to launch a project in the maritime or blue technology sectors today?
I think the answer can apply to both. I think, of course, the driver in the marine industry, and it's probably the same in the water industry as a whole, is sustainability. It takes different aspects. For the marine industry, we talk a lot about decarbonization, but we should not overlook that the sustainability as a whole and the respect to the environment is also one of the big axes of development. We talk about noise reduction, we talk about the preservation of wildlife in ports and such and so on. And what we noticed, if you look at, for instance, our experience in ballast water treatment that discussed in up to 2004 and then ratified and then applied 2017, it took a lot of time. That changes in our industries are a journey. It takes time. It takes quite a lot of time. And two important aspects are the collaboration between the stakeholders and then also taking in account the timeline aspects. And we sometimes talk about technologies that are going to be disruptive. Probably they will. But when it comes to sustainability, one step at a time is a good thing. Probably the solutions in our different challenges are a mix of solutions, some of them being applicable today, while not being perfect maybe, and others that maybe are sounds or looks better, but are not ready yet to be on the market because in our industries, a lot of stakeholders can have to be involved, and it's a process that takes time. So I believe that's one of the things I would say, is to know where you are in this timeline and what you're offering the market. Are you the disruption of tomorrow? Are you the solution for today? And be always aware that solutions are most of the time comes with a S. So it's a composition of different things to do.
I like what you just said. I like the fact that we need a combination of solution. The timeline is really important, and we have imperfect solution for the future, but also we need solutions that are not perfect regarding all the sustainable and regulation right now that we need for today. So it's step by step regarding the innovativeness and the regulation and the sustainability. So thank you, Maxime, for sharing your insights and expertise and for showing us how UV technology is quietly transforming the water treatment from the ballast water and aquaculture to offshore wind and beyond the swimming pool. And thank you all to our listener for joining us on BlueTech Around the World. If you enjoy this episode, don't forget to subscribe, share it with your network. And until next time, stay curious and keep innovative for the blue economy. Thank you again, Maxime, for being with us today.
Thank you, Marilou. It was a great pleasure.
Thank you.